All right, so we're looking at coordinate geometry. The objectives of this lesson. At the end of this lesson, students should be able to plot points on a coordinate plane, determine the x and y intercepts of a straight line. So we have the coordinate plane, what is known as a coordinate plane. A plane is basically a flat surface, or is divided into the four quadrants, four quarters, right? We have the x-axis, which is a horizontal line running from left to right. We also have the vertical axis, or the y-axis, which runs from top to bottom, up and down, vertical. Now, the axes are basically number lines, where both axes meet. So we have the x-axis, again, we have the x-axis. So leave it as an x, sometime we can put the axis on it. We have the y-axis right here. Where they intersect is referred to as the origin. You can think of that as the beginning. 0. 0 on the x-axis and 0 on the y-axis. However, to the right of the origin, we have the positive x-axis. The positive x-axis. Positive x-axis. And to the left, we have the negative x-axis. It's really one x-axis, but of course, to the left-hand side, we have the negative side of the x-axis and the positive side of the x-axis on the right of the origin. Likewise, for the y-axis, below the origin, we have the negative y-axis. In other words, that part of the y-axis where we have the negative values. And above the origin, we have the positive y-axis. In other words, that part of the y-axis that is positive. As mentioned, both axes divide the coordinate plane or Cartesian plane into four quadrants. These quadrants start from the positive x-axis and positive y-axis. So let's look at that. So this part is a positive y-axis. This part is a positive. And so in this section here, we have all positive x and y values. This is our first quadrant, quadrant number 1. Let's examine quadrant number 1 some more. All right, so looking at quadrant number 1. All right, so now looking at the first quadrant, which is right here, we have positive x and y location. In other words, let's say you are actually at this position right here. So Mrs. Woolery, you're at this position right here. So this is Mrs. Woolery. What is your location via the x-axis? Remember, the horizontal line going from left to right is our x-axis. What is your location via the x-axis? To determine your location via x-axis, you'll actually walk straight downwards, parallel to the y-axis. When I say parallel, in the same direction. So imagine that this point here is on the y-axis, and you go straight down vertically. In other words, you're moving parallel to the y-axis to meet the x-axis. What number on the x-axis will you actually stop at once you reach the x-axis?
Is it 4?
Yes, 4 is correct. So your location via the x-axis is 4. Now, we call that the x-coordinate. In other words, the x location of point W. So we're going to basically put a pair of brackets and a comma in between. In the first part, we put the x coordinate, in other words, the x location. And in the second part here, we put the y location. That's the standard. X, then y, just like the alphabet, x, y. So the first will always be the x location, and the second will always be the y location. We call it the x coordinate and the y coordinate. The x and y coordinate together for a point, basically, because every point on the coordinate plane will have an x coordinate, an x location, and a y location. In other words, you'll be able to identify it via both locations. So you're here. Your x location is 4. So let's put that in. What is your y location? What do you think you'd have to do to get your y location?
I think moving the point to the left and head straight over to the 3.
Right. So you're going to move straight to the left. And when you do that, when you move straight over to the 3, let's look at that. Let's see you move straight over to the 3. So you're basically here, and you move straight over to the 3. Right. And so this will actually give you what? This will actually give you the what?
Value for y.
Yes, the y coordinate. And that will be 3.
Y coordinate.
Thank you. So that's very good. So that you have identified the location of the W via the x-axis and the y-axis. The location is 4, 3. All right. Let's look at another one. Let's say you're actually standing, let's say you're standing over here. Let's go from a completely, let's go over here. Now we're moving from the first quadrant to the second quadrant. So this is the first quadrant. Remember, the y-axis and the x-axis divides the coordinate plane into 4 parts. So right here is our, over here is the first quadrant. Over here now is our second quadrant, which is made up of the negative x-axis and the positive y-axis. In other words, the y location for any point in this region will be positive, and the x location for any point in this region will be negative. Okay, so let's say your friend L is at this location. Would you be able to identify your friend's location via the x-axis and the y-axis? Can you identify the x location?
Yes.
Go ahead.
It's -4.
-4. Very good. So how did you get that?
By bringing the point down.
Okay, good. So
to the right.
Okay, very good. So you would have stayed. So your point is here, and you go straight down,
Right.
and it hits the x-axis at -4. Very good. And what about the y location? What is the y location?
Y location would be 3.
Right, very good. And we can say this this is +3, correct?
Right.
So you go straight across, and you hit the y location at +3. Very good.
Thank you.
And so this will be +3. All right, so this is quadrant 2. Let's go down to the next quadrant. So in the next quadrant, let's see how well you do with that one. This one, I'm gonna ask this question. For this quadrant down here, what do you think the x coordinates, what would be this sign of the x coordinate? Will it be positive or negative?
I think it will be
You can look at it.
negative for the x coordinate and negative for the y coordinate.
Very good. And as you can see, the x axis, this side of the x axis is negative, and this side of the y axis is negative as well. So that's great. Excellent. Now, if we are to locate a point here, for example, um, let's locate a point. In fact, let's do the one here. Now, we're not seeing a label here, but let's see if you'll be able to pick this up based on the units you're seeing on the axis, this distance between each unit. So I want to focus on that. All right.
Okay.
Let's say we have D. That's another friend's. That's another friend's location. What will be the location of D via the X and the Y axis? Remember, we always go with X first, then Y, just like the alphabet. X, then Y. That's the standard.
Okay.
What will be the X location and what will be the Y location?
So x location would be -6 at the
Okay, so let's, one moment. So you're gonna go up there to the X location with -6. All right.
right.
How did you figure that out? If you don't mind me asking.
I followed the pattern counting from the center of the origin and going back to the left and counting right up to 6 and keeping the sign.
Right, so -1, -2, -3, -4, -5, and so this distance must be the same distance from -4 to 5 is 1 unit. So this should be -6. Very good. Well explained. And so this will be -6 for the X location. And what about the Y location? What do you think that should be?
The y location, that would be -3.
Right, so from the point, we go straight across, and we basically will hit the y-axis at -3. Very
Right.
good. All right, so this will be -3. Very good. Now, what do you think the sign of this quadrant will be? The signs for this quadrant in terms of the x and y coordinates. One moment. So we have this quadrant. Which side of the x axis will be using, and which side of the y axis we will be using?
We're going to be using positive for the x
Okay, so we're using
axis,
positive for the x-axis, and you're correct.
right?
This side of the x-axis is positive, both in the first quadrant and in the fourth quadrant, as you can see. All right, what about the y-axis for this region?
The y-axis for that region would be negative.
Very good. And so it's actually negative for any point in this quadrant as well as this quadrant, the third and the fourth quadrant. The y coordinates of any point will be negative. So for this point in the third quadrant, we recognize that the y location is -3. And for any point in this region, the y location would also be negative. But let's select a point in this region. Let's select this point here. And say, let's say you have a friend with this letter M. What is the location of this point? Let's start with the x coordinate and then go to the y coordinate.
Okay, y coordinate would be 1, +1.
Okay, so which coordinate are we looking at? Which coordinate do we
We're
use
looking at
first?
x, the x-axis.
X-axis, very good. So the x coordinate will be
+1.
+1, and the y coordinate will be,
Y coordinate would be -1.
okay, so let's look at that again. So the y coordinate, the x coordinate, we always go with x first. It's easy to make the mistake of going with the y, but the x coordinate, we always want to look at first. So from the point, we go straight to the x-axis, and it's the positive x-axis we're looking at, and so that's +1. And then we go to the the next, what we're looking at next is going to be the y coordinate, the y location. And so we're going to take the point and we're going to go across and check to see where it will hit the y-axis. And it will hit the y-axis at -1, as you clearly stated. Very good.
Right.
And so the location of this point is at 1, -1. Very good.
Thank you.
All right, Mrs. Woolery, do you have any question?
Yes, I do have a question. Can the points be placed outside of a line, meaning can it be placed in the middle of a unit?
Sure. Let's look at that. So let's say that, are you referring to, when you say outside of the line, do you mean the intersection of these lines that you're seeing?
Right, outside of the intersection.
Right. So if your point is right here, for example, let's use green color there. Like the point could be right here. That's what you're saying?
Yes, or can it be placed in the middle of the unit?
Okay. Right. And what we call these, for example, square units. This is one. This is actually a square. And
Right.
so this length is 1 unit, and this would also be 1 unit. Going up, if you look at the y-axis, from 0 to 1 is 1 unit. So we can measure this length across using the y-axis. So from here to here is 1 unit, as it's with the same length as this to this. So this is 1 unit by 1 unit. So we call it 1 square unit. So you're referring into in the middle. So let's see.
Okay.
All right, so let's look at that. So let's say we have a point being at the center right here. What would be the location of this point? All right, so basically, Mrs. Rulery, is that these lines that you're seeing, the dotted lines, fine dotted lines you're seeing, is just to help us to identify clear points, and that these points will be for whole number, for integers. And when we talk about integers, we're talking about positive whole numbers and negative whole numbers. Whole numbers meaning no fractional parts. So looking at this point, the intersection of this line and this line, if you go straight down, you realize it hit the positive x-axis at +4. And this point, when you go across to the y-axis, hits it at +3. Here again, a whole number. However, the points can actually fall in between whole numbers. So if we look at this point here in green, let me just put a point here in the center of that. Okay, let's go down and see exactly what happened in here. All right, so let's say we take this arrow and we go down. One moment, please.
Sure.
All right, so let's illustrate. Let's look at this point again. If I should go straight down, where does it hit the x-axis? What value
It
does it?
hits 1, +1.
It's +1. All right, so it is +1. And what about the y value? Where do you think the y value, where would it hit the y value?
Looks like it's hitting, is it 1.5?
Yes, very good. It looks central, halfway between 1 and 2, and so that'd be 1.5. However, it could be 1.49, for example, right? It could be 1.49, which
Right.
1.49 is very close. Like, think of 49 being close to 50, right? So
Yeah.
1.49 is close to 1.50. And 1.50 is same thing as 1.5. We're just not putting on the two decimal place, which is the zero at the end. So 1.5. All right, but it's very hard to tell. We know it's very close or look very central, but it's very hard to tell. So what we'd have to perhaps do is to, if we had 1.5 labeled here, exactly where this line hits, then we'll be able to tell, right?
Right.
So it depends on the scale that you have and the division of the line, right? Where they have the actual labeling of the values on that particular axis. So without that, it's hard to tell. So that's why we actually have these lines. Now, if we had lines running through, for example, halfway in between these units, between 1 and
Right.
2, right? If you have a line that runs right through it, then we'll be able to say that yes, it's definitely going to be. So for example, let's say we had a line that runs through it like this, right? And and we have other lines that run through this one as well, the same way, going through halfway through it, right? Then we'll definitely know because we can actually see that this actually hits it exactly on the line, right? Actually run through this point. So this point here, we can definitely see that this point here, right, is actually this point here. Let me just choose a different color. Yes, this point right here is actually on this line, and this line is halfway between 1 and 2. And so be able to say this square is located at 1 and 1.5 or 1.5, right? So the location of this point will be 1, comma, 1.5 or 1.5. But without this line drawn, it's very hard to tell. But
That's true.
typically on a graph paper, it's divided a little bit more. And so be able to say, yes, it's going to be 1.5. All right. But without that, it would be an estimate. We can say it's approximately 1.5. And so if we look at this point over here, let's leave this line drawn through. All right. Let's say we have this coordinate plane being divided similarly, and this point is actually on this line, right? And then we have another line. Let's say we have the coordinate plane be divided like that. So, and then we have a line running through this, right? We have a line running through it. Then it's easy for us to now say that, okay, yes, for this point here, right? Its location will be what? What its location will be? Go ahead, tell me.
Okay, its location on the x-axis would be um 1.5
On the
or one and a
x-axis,
half
let's go
on
again.
the x-axis.
Okay, let's go again. Look at the x-axis.
Sorry, on the y-axis, but let me do the x first. Sorry about that.
No, that's fine. Go ahead.
The location for the x-axis will be um 3.5.
3.5. Very good. So that'll be 3.5, or we can say 3.5, right?
3.5,
Uh-huh.
right? And location for the y-axis will be 1.5.
Right, or 1.5. Very good. Very good. So yes, so that's the idea. That's the idea, right?
Okay.
So your graph paper will definitely be divided into smaller portions, and so you'll be able to see the lines where the lines are running and have a greater estimate of what the actual values for the x coordinate and the y coordinate will be. But what I can clearly say is that so far, you basically have a great idea as to how to identify the x and y coordinate. Okay, so let's continue. You have any more questions, or that's it for now?
And that's it for now.
Okay, so let's move on to the next portion where you'll be basically um, labeling some coordinates for practice. All right, so Mrs. Woolery, let's find the location of these points on the x and y axis. In other words, we want to label the coordinates for each point. Ready?
Sure.
Okay, all right, good. Let's see how many of these you can actually get correct. Let's start with point A. What is the location of point A?
Okay. Point A located on the x-axis will be +3, and location for the y-axis is +3.
Okay, so the location is 3, 3. All right, good. What about point B?
Point B on the x-axis is located at +5, and the y-axis is +4.
Very good. So its location is, in a shorter form of saying it, its location is?
Its location is 5, 4.
Very good. Give me the location for this one.
Location for
Point C.
C on the x-axis is -3, and location for the y-axis is +1.
Very good. All right, let's look at the other one. Point D.
Okay, location for point D on the x-axis is -2.
On the y-axis.
And sorry?
Go ahead.
Yeah, and the location for the y-axis is -1.
Okay. So location of the point via the y-axis will be -1. All right, good. Next.
Location for H on the x-axis is -4.
All right, -4.
And on the y-axis is -y. Sorry, -2.
-2. All right, good. So it's a negative y-axis and
Right.
-2 on that y-axis. Okay, great. All right, let's go with F. Location for F.
Location for F on the x-axis is +4. Location for F on the y-axis is -1.
Very good. All right, I want to give him the location for G, but just give me the two values, the short form.
Okay.
Location of point G is?
Location of point G is +6 and -2.
Excellent. So you got, let's see, 100%. Very good.
Yay!
All right, ready for the next challenge?
Sure.
All right, so we're looking now at the equation of a straight line. But before we get there, what we want to be able to do. All right, so now we're looking at intercepts. Now, when you say intercepts, what do we really mean by intercept? Well, intercept basically for equation of a straight line or the graph of straight lines is where the graphs basically intercept or cuts through or touch the x and y axis. So if we're looking at two lines, so let me just look at two lines here. Let's say we have this line, so we have that line, and we have another line. this line here, and they intercept each other. When we say they intercept each other, what we really mean is where they basically, the point in which they actually cut through each other or touch each other. So this orange line intercepts this blue line at this point right here. So let me just highlight that right at this point here. All right. So you can still see where they actually intersect. So the word, so intersect or intercept could be synonymous in this situation. So this line intersects this line or intercepts this line at this point right here. The point of intersection or intersection will be the point in which they intercept. All right. So Patrice, is that understood?
Yes, it is.
Okay. So let's look at this line, this straight line, or we call it a graph. Anything that we draw on the coordinate plane, and I'm sure you can think about, you're probably asking, why do we call this coordinate? All right, coordinate meaning it has x location and a y location, and so we call those coordinates. The x and y values are coordinating for the point, right? Or the x values, the y value depends on the x values. So there's a bit of coordination, if you want to call it that. So you have an x coordinate, y coordinate. So because it's a plane, flat surface, we call it coordinate plane because we're able to generate points, and each point has x and y locations. So in other words, a coordinate plane. Okay, so this is the graph that we have on this coordinate plane. Now, mind you, this is also a graph here. Anything that we draw on it is considered to be a graph. So we're taking off this. Even this little yellow, not yellow, but green shading would be a graph as well. So we're going to take that out. So it's not want to refer to these, right? Okay. So for this graph of the straight line, the question is, what are its intercepts? In other words, where does this graph intercept the y-axis, and where does it intercept the x-axis? All it's asking for are the values on the x and y and the y-axis, where the graph intercepts both of those axes. So again, let's start with the y-axis. What is the y-intercept? In other words, we're on the y-axis. This graph intercepts the
It
y-axis.
intersects the y-axis at 1.
Right.
Positive
Okay.
1.
So the word we're looking at is intercept, right?
Intercepts.
Right. We can also say intersects, but we're looking at intercept because there's a special name given to where the graph cuts or intersects the x and y axis. We call it the intercept for where the graph intercepts the y axis. We call it the x-intercept for where the graph intercepts the x axis. So you said the graph intercepts the y axis at 1, so that will be right here, and this will be called the y-intercept, where the graph intercepts the y-axis. This is our y-axis. And so the y-intercept is, what value you got?
Positive 1.
Positive 1. Very good. What is the x-intercept? What is the x-intercept?
The x-intercept is negative 1.
Right, where the graph intercepts the x-axis. So the x-intercept is equal to negative 1. Very good. Now, besides the y-intercept and the x-intercept, we also have what we call the x-intercept point and the y-intercept point. Of course, you know, where the graph intercepts the y-axis is also a point. So if we should identify this as a point right here, remember every point has an X location and a Y location. So let me ask you, what is the Y-intercept point? What is the Y-intercept point? So we're gonna start right there. What is the Y-intercept point? Yes, the Y-intercept is just one. We call it the
Right.
Y-intercept. But what is the Y-intercept point? Look at the point where the graph intercepts the Y-axis. What is its X location? Remember, to get its X location, what do we need to do?
At X location, we are going to, are we doing,
Go ahead, ask. That's fine.
are we doing the first, the section A?
Are we doing the?
Are we over in A, like section A?
Oh, well, no, no, we're not. We're not actually in any particular section. The point is
Okay.
actually on the axis itself. If you look at this point,
Right.
do you notice actually it's actually on the axis itself?
Yeah.
Right. So that's a very good question. Very good question. Since it's actually on the axis, we wouldn't identify it as being in any one of the quadrants or any of
Um,
the sections or the quadrants, but we will identify
okay.
it as being on the axis. So that's a very good
Right.
point you make, and we're gonna make a little note of something once you'll be able to identify the location of the y-intercept as well as the x-intercept in terms of its coordinates. Its x-coordinate and y-coordinate for the y-intercept. Let's start with that one. Remember, when you have a
Okay.
point, what do? You move from what? Wherever the point is located. Okay, so let's do a recap of that. Let's say we have a point here. How do we get its location? What do we do?
We're moving it. We're gonna look in. If we're looking for the x-axis, we're moving it down.
Right. So we're gonna move it down to the x-axis, and we get its what?
Right.
We get its
And
if we,
sorry.
and then we get its x location, which in this case will be what?
Right. That will be +6.
Very good. And its y location will be what?
Y location will be +2.
So we go across to the y-axis, and
Right.
its y location will be +2. Very good. But since we're talking about the this point that is on the y-axis, but it's a point
Right.
nevertheless, we want to do the
Right.
same thing. We want to identify, we're going to do what? How do you identify where the its
We're
location on
gonna
the,
go upwards.
well, where the point is, and
Uh-huh.
look at where the x-axis is. So where do we need
Right.
to go towards the x-axis?
Okay, I get what you're saying. So we're moving the point down to the -1
No,
on the x-axis.
the negative one. Which negative one?
Um,
That's okay. Go ahead. Remember that this is the x-axis. Are you seeing
right.
the mouse
Yeah.
point? This is the
Right.
x-axis. So you're not gonna move away from, you're not gonna go below this. Anything below this is not the, well, it's not
Okay.
on the x-axis itself. We're looking at moving the point until it hits this axis. If you move this
Right.
point down, where does it hit the x-axis?
It goes right to the origin.
Very good. So it's gonna go right to the origin. Right here. It's on the x-axis, right?
Oh, I was moving it like to the left down to -1, so probably that's where I wasn't
O-
understanding.
Okay.
I was moving it to the left, like moving the point down to -1,
Okay,
not
on the
right.
graph itself.
Yeah.
Okay. So remember where the point, these points that are actually on the coordinate plane, you were actually going straight to the x-axis, and you were moving the points parallel to the y-axis. If you
Okay.
move this along this line, it is no longer parallel. The movement is no longer parallel to the y-axis.
Okay.
You know what parallel lines are, right? So if you have a line like this running like this, a parallel line to this line will actually look like this.
Right.
They're heading in the same direction, but they will never meet, right?
Right.
So the y-axis is upright. So this is the y-axis, a line that's parallel to the y. All these lines here, look, all these lines here are running parallel to the what? The y-axis. The y-axis goes up and down. And these lines also move what? Up and down. So if you
Right.
want for any point on a coordinate plane, no matter where they are, for them to hit the x-axis, to give the x location, you need to move the point, that particular point, parallel to the y-axis. So if you look at this point here, do you realize this arrow that goes down is actually parallel to the y-axis?
Right.
Right. And so in order for you to go to hit the x-axis, you need to move the point parallel to the y-axis. For you to move the point to hit the y-axis, you need to move it parallel to the x-axis. Look at this line that hits the y-axis. It's running parallel to the x-axis.
Yeah.
All right. Understand
Okay.
that?
Yeah.
Okay, good. So wherever the point is, you need to move it parallel to the other axis to identify where it is on the particular axis. So we're
Right.
trying to identify the x coordinate. So you need to move the point parallel to the y-axis, in the same direction as the y-axis, in other words.
Okay.
Is that clear?
Yeah.
Okay, good. So this point, you need to move it where?
Down to the
Straight,
origin.
straight down, parallel in the same direction as the y-axis. If it's over here, same direction, down. It's up and down only to hit the x-axis, okay?
Okay.
So glad we got that clarified. So let's test your knowledge. Let's say we have this point here. Where, if I want to identify its x location, where do I go? Do I go up? Do I go down? Do I go left? Do right? Do I go left? Do I go sideways? How do I get to
We
the
go. We are gonna go upwards
right? So it must
in a
either
straight
be,
line.
so to hit the x-axis, you either move what? Upwards or
Downwards.
downwards. Very good. In this case, because it's below the x-axis, we need to move it upwards. Because it's above the x-axis, we need to move it downwards. All right, very good.
Right.
So let's look at this point. Do we need to we need how are we gonna move this point? Upwards or downwards?
We're finding what
Coordinate,
the
yes.
x coordinate
Yes.
downward
Downwards. And what's its location? The x
0.
location, 0. Very good. Okay, very good. What do you think its y location will be?
For its y location, we're gonna move it upwards.
Okay. But if you move it upwards, it's gonna hit all the values. Do you see that it's gonna hit all the values on the y-axis?
Right.
And where would you stop? Where would you stop? Remember upwards and
Stop at
downwards.
2.
Remember upwards and downwards relates to what? Moving the point towards the x-axis.
Right.
Upwards and downwards relates to moving the point towards the x-axis.
X axis.
Yes. So for this point, for example, again, we move it downwards to hit the x-axis. For this point, we move it upwards to hit the x-axis.
Right.
Let's go back. Let's go back a bit to ensure that you're understanding. Let's go back to this. Let's go back to this. As we can clearly see here, as we can see here, one moment. Let's remove these. All right. As we can see here, let's identify point A. How did we get the location of point A on the y-axis for this
We're moving
y-axis here?
it. Right.
Which direction?
We're moving it to the left.
Move it to the left. How do we get the location of the y coordinate for this point? Move it to what direction?
We're moving to the right.
Okay. For this location, how do we get the y coordinate?
We're moving to the right.
And how do we get the coordinate for the y? What do we get the y coordinate for this point?
We're moving it to the y coordinate, you said?
Yes.
We're moving it to the left.
So for the y coordinate, what direction do we move the point? What location, what directions? As in
We're
the
moving it
examples,
to the left or the right?
over to the left or the right. So let's go back to this. For this point, how do we how would we identify its y location?
We identify its y location by moving it to the left or the right.
Okay, but let's go back to this one more time. When we move this point to the left, to the right, when did we stop? When did we stop?
At at 1,
Okay, why did we stop? But where is one located?
1 is located at the origin
No, no, the
of
origin is right
the
here.
sorry,
The one is located where? This one.
it's located at the y-axis.
On the y-axis. Very good.
On the y-axis,
Right. Where is this? Why? Where is the y value said is 3? Where is it located?
on the y-axis,
On the y-axis. Let's go back to this point. If you move this point to the left or to the right, will it be on the y-axis?
no.
No. So what do you think the y location of this point is?
The y location of that point is 1.
Right. It's already what?
It's already on the y-axis.
Very good. But for the others, they weren't on the y-axis. We have to move it towards the y-axis to identify its y location. But this one is already at the y location itself. So its y
Right.
location is 1.
Yeah.
Very good. Understand?
Yeah, I understand.
Right. It's a little bit more tricky than the others, but now you get it. I mean, I'm sure you understand it a lot better now. Let's look at
Yeah.
this. Let's look at another. Let's look at some. Let's look at some more y-intercept before we actually go to the x-intercepts. I think that will be good. Let's do that now. What do you think is the one moment? All right. So, what do you think is the y-intercept of this graph? What do you think is the y-intercept for this graph? The y-intercept. Remember what the y-intercept is, right?
Yeah, the y-intercept for that graph is at -2.
Yes. So the y-intercept is what?
Um,
Where the graph hits the
where the graph hits the y on the y-axis.
right, where the graph hits the y-axis. Where the graph hits or pass through or intercepts the y-axis, right?
Right.
So you can use the word intercepts. So where the graph intercepts the y-axis. We call it the
Okay.
y-intercept. All right. And its value is what?
-2.
-2. All right, very good. I want to go back a little bit though. I want to go back a little bit. Sorry about that. All right. You did give me the values for the y-axis, for the y-intercept. You said that the y for the y-intercept point, it's called a y-intercept for the y-intercept point. The x location you said was what again? Remind me. So,
The x locate
of this point. We call it the
the
y-intercept
x
point, right?
location of that point is 0.
Right. We call it the y-intercept point. And what is y? What's its y location?
Y location is 1.
1. Do you see any relationship between the y-intercept and the y location?
Um, the locate
The location. Okay. Let me go over that again. Do you see any relationship between the y-intercept value of 1 and the y-coordinate of the y-intercept point?
Is it that it's like one is it like one
Yes.
unit?
Well, true. It's 1 unit, but not just 1 unit, but what? What's the value?
The value is one.
1. 1 unit simply means from 0 to 1 is 1 unit, from 1 to 2 is 1 unit, from 2 to 3 is 1 unit. But specifically, looking at this point, its y-intercept is 1 because it cuts the y-axis at 1. And for the y-intercept point, its location is 0, 1. So the question is, what is the relationship between the y-intercept value of 1 and the y-coordinate that you're seeing? The y-coordinate you're seeing here is what? What's the y-coordinate of this point?
One.
So what can we say about the y-intercept value of 1 and the y-coordinate of the y-intercept point? They are what?
They are identical.
Or we can say they are what? The same.
The same.
Yes, very good. All right, so very good, very good. You're doing well. All right, so let's go to Xintercept then. Let's go to the Xintercept. I know I said that I will look at another y-intercept, but let's look at the Xintercept of this point. The Xintercept is what? -1, correct?
Correct.
Where the graph intercepts the x-axis. But it's a
Right.
point as well. This is actually a point. Remember, every point has a what? Has two coordinates. So what are the coordinates of this particular point? We call it the x-intercept point. What are the coordinates of the x-intercept point? What are the coordinates of the x-intercept point? Let's go.
Okay, so the coordinates of the x-intercept is -1.
So the coordinates will be -1. Go ahead.
Yeah, so it's -1. And
Coordinates will be -1. That's the x location, right?
right.
Right. Very good.
The y location you're asking for now,
Yes.
that will be 0.
Very good. Very good. So you recognize the y location is going from left and right, right? Until we are on the y-axis, correct?
Right.
And if we're already on the y-axis, we just call it the value there. But the y coordinate, we have to move across to the left because we're not on it. And once we get on it, we stop right there. And where we
To the
stop
left or
is,
to the right?
well, to the right, sorry, yes.
Okay.
We're moving to the right, and once we're on the y-axis, that's the y value that we're taking off. We're reading off. We're reading 0. So the y
Okay.
coordinate is 0. The y location of this point is 0. And its x location is actually on the x-axis. Since we're already on the x-axis, we don't need to do what? We don't need to move up or down, right?
Right.
If we move up, we're off the x-axis. If we move down, we're off the x-axis. We're not going to hit the
Right.
x-axis. We're already hitting the x-axis already.
Yeah, that's true.
But for a point that is off, for example, like in these examples, like for C, we notice the x location is -3, but we had to go down to hit it, right?
Right.
But here, we're already hitting the x-axis immediately at -1. So that's the x coordinate. And the y coordinate, we now have to move across to the right to actually hit.
Right.
So the location is -1, 0 for this point. We call it the x-intercept point because it is actually where the graph intercepts. It's a point where the graph intercepts
Right.
the x-axis. So hence the x-intercept. So the graph intercepts the x-axis at that point. But if we talk about the x-intercept value, we just simply say -1. Understand?
Right.
Okay, good. So, do you understand when we say intercept and when we say intercept point? When we say intercept, we're asking for how many values? Our value.
So when we say intercept, we're asking for the x-axis value and the y-axis value, and the intercept point is the um where the line intercepts with the axis.
Okay, let's go over that again. I think what you're saying is correct. However, it construed differently still. So
Yeah.
look at the x-intercept. We have x-intercept equal to how many values? Our value. Look what we're saying.
One.
1. When we say y-intercept, how many
So
values are we seeing? When we say y,
one.
we're seeing 1, right? But when we say y, when we say intercept point, how many values are we looking at?
We're looking at two.
Right. So let's put that x-intercept point. So what's the difference between the x-intercept point and x-intercept, or the y-intercept point and y-intercept?
The difference between the two
Yeah.
is that they have the same, the negative one, they have the same value.
Okay. True. For the
Is
x-intercept,
that
for the x-intercept, we see -1, and in the x-intercept point, the x-coordinate is -1.
right?
For the y-intercept, the y value is -1, is +1, and the y value of the y-intercept point is +1. Very good. I'm
Right.
happy that you see that that or I did be able to identify that point that you're making. But what I'm asking though, however, what is the difference between the x-intercept and the x-intercept point? What difference are you recognizing between the intercept and the intercept point? What's the difference? If you were asked to state the x-intercept, would you give me two coordinates or one?
I'll give you one for the intercept,
Okay. And for the point?
and for the point, I'll give you two.
Okay, great. So that's the difference I'm making note of. That for the intercept,
Okay.
there's only one value. You're just reading off the value that you see on the either the x-axis or the y-axis, depending on which intercept you're asked for. So if they ask you for the x-intercept, you just simply read off the x value. If they ask you for the y-intercept, you simply read off the. If they ask for the y-intercept, you simply read off what?
If they ask for the y-intercept, you read off of the y-axis.
Right. So you take off the y value. Right.
Okay.
Right. Take off the y value from the y-axis. Yes, from the y-axis, and you take off the x value of the x-axis from for the x-intercept. Okay, great. But for the x-intercept point, you need two coordinates, right? So you look at the point and you take its x location and its y location for the x-intercept point. For the y-intercept point, you're taking its x location as well as its y location. Understand?
Yeah.
Okay. Let's see if you really got that. Let's look at this example here. So, say for me, you're gonna state um, for this, you're gonna state the x-intercept. You're gonna state the y-intercept. You're gonna state the x-intercept coordinates of the x-intercept point, or the coordinates for the y-intercept point. So go ahead.
Okay. The x-intercept is 2,
2. The y-intercept is.
and the y-intercept is -2,
hmm Go ahead.
and the x-intercept points.
hmm
Give me a second.
Sure.
The x-intercept point is 0.
Okay, so let's start with what you gave for the first one. You gave the first one as x-intercept is 2. So this is x-intercept, correct?
Yeah.
That's the x-intercept. Very good. And you said the y-intercept is negative 2,
Negative 2.
which is right here. So that's the y-intercept. Okay, very good. Next, the x-intercept point. The coordinates of the x-intercept point. When you hear point, what comes to your mind? If you identify a point, what comes to your mind? Based on what we looked at before. Every point has what? So if you can remember.
Every point has a um,
Has an,
units.
go ahead.
Every point has a unit. No.
Not a unit.
Um,
That's not what we're looking for now.
every point has an intersection.
That's true.
An interception. Um, 2 coordinates.
That's what we're looking for. Very good. Every point has 2 coordinates. So
Okay.
once you hear 2 coordinates, you know we're dealing with a point.
Okay.
So looking at a point, remember we said you're standing at a particular point. Remember that?
Yeah.
And you have an x location and a y location.
Yeah.
Okay, good. So that's the thing we're looking for. So every point has 2 coordinates. So when you see the request for the coordinates of the x-intercept or the x-intercept point or the y-intercept point, we're looking for the x coordinate and the y coordinate. So you ask for the coordinates of the x-intercept point. But once you hear point, you're looking for 2 coordinates. So what are they for the x-intercept? Let's start with the x-intercept.
X-intercept.
Yes, the
It's 2.
coordinates. Coordinates,
The
the coordinates.
coordinates. Sorry.
So you're looking for 2 values. So this
Okay.
point, this location here, again, is a point. Even though we read off 2 as the x-intercept, we're looking at the point now. The point has a location. What's the location of this point? On the x-axis and then the y-axis. What's its x
On the
location?
on X location it's 2.
And what's its y location?
Y location it's 0.
Right. So can you remember now that the point has 2 coordinates?
Yeah.
An x location and y location? Okay, good. So I want you to remember this.
Okay.
Let's look at the y-intercept now. But,
The
but for
Y
the point though, we're looking at the y, not just the y-intercept. We know the y-intercept is -2. But what is its y? What is the y and x location or x and y location
Okay.
for this point?
The the location for Y
No.
is negative.
Okay, yes. Okay, the y location is
The Y location is -2.
the y location of the point, right?
The location of the point is -2.
Okay, but I have to put it over here since I have to write the x location first. What's the x
Okay, I
location?
understand. Yeah, I should have done the X first. Sorry.
That's fine.
Um, Y is -2 and X is 0.
Okay, good. It's gonna take a little bit of time, so just be patient with yourself. We're getting it right, but we'll have to
Okay.
repeat it over until you get it. So the x-intercept point has an x location and a y location. Once you hear point, you're thinking of the point has in where it's located on the x-axis and on the y-axis. Since it's already on the x-axis, we already have its location on the x-axis, right?
So you're saying the x-intercept point has two locations,
Just like any other point.
right? So it has the x, what do you call that? The x interception point?
We'll just call it x-intercept point. X-intercept with a P.
Okay.
X-intercept
Oh,
point.
okay.
Hmm.
All right. Understand.
Yeah. So when they ask for the x-intercept, you just read off from the x-axis where the graph cuts it, the x value.
Okay.
So basically, this is it. Let me explain. So for the x-intercept point, the x value is called the x-intercept. For the y-intercept point, the y value is called the y-intercept. Are you seeing that?
Yeah.
Let's look at it. For the x-intercept point, you said it's 2, 0, correct?
Yeah.
The x value is called the x-intercept. Do you see that they're the same?
Yeah.
The x-intercept is 2. The x-intercept here, we said it's 2. And that's the same value in the x-intercept point. So the
Right.
x value in the x-intercept point is called the x-intercept. And the y value in the y-intercept point is called the y-intercept. That's why we have -2 in the y-intercept point as we have -2 for the y-intercept. Got it?
Yeah.
Okay, another thing you probably realize as well too, that any point on the x-axis, the y value is what? Any point on the x-axis, what's the y value?
Any point on the x-axis,
Hmm.
what is the y value?
Yeah, what is the y coordinate for any point on the x-axis? What is the y coordinate of any point on the x-axis?
The y coordinate is negative.
No, think about it, what I'm asking. The y
Uh-huh.
coordinate. What is the y coordinate? The location of
Is
the point on the
y,
y-axis.
right?
So I'm not asking about the x coordinate, I'm asking about the y coordinate.
Uh-huh.
So if I have a point here on this x-axis, what is its y location? What's the y location of this point?
The y location is going to be 0.
Okay, let me move this point and put it here. What is the y location of this point?
0.
Okay, what's the y location of this point?
0.
Correct? What's the y location of this point? Right here.
That is also 0.
Right, very good. You're simply doing the same thing you're doing all along, just moving towards the y-axis and hit the y-axis. All right, so what's the y location of this point here?
0.
Very good. And for this point over here? Right. So any point, so again, so my question is, for any point on the y-axis, sorry, for any point on the x-axis, what is the y value? For any point on this x-axis, what's the y value?
0.
0. We call the x-axis the y equals 0 axis. What is the y location of this point? You told me the y location is 0. What's the y
Right.
location of this point? You told me that the y location is 0. What's the y location of this point? You told me that the y location is 0. So my question is, why do you think they call this axis the y equals 0 axis? Y in this case is equal to what? 0. Y coordinate of this is equal to what? 0. Y location of this point is equal to 0. While x is -3, as we can see, while x is perhaps about -1.5, while x is about well, right here will be 5. Although this is the x-axis, every point on it has a y coordinate of 0. Are you seeing that?
Yeah.
Right, so we call it the y equals 0 axis because all the points on this axis, the x-axis, all the points on the x-axis, y for all the points on the x-axis, y is 0. So rather than saying the x-axis, we can call it, we can say the y equals 0 axis because every point found on it, y is 0. For every point on the, let's look at let's look at this. Look at this point right here.
For every point on the y-axis, x is equal to 0.
Okay, let's test it out and see. For this point here, what's the x value for this point? What's the x value for this point? What's the x value for this point?
0.
0. How do you know that? It's 0.
Because it's right there on the y-axis.
Yeah, but how do we know that it's 0?
Because we're moving upwards.
To hit the x-axis, correct?
Right.
And when we move up to hit the x-axis, we hit the x-axis at 0.
0.
Right. Although the y value is -2, which is also called the y-intercept. The -2 is called the y-intercept, where the graph intercept the y-axis. But together we call it the y-intercept point. It's a point because it has two pure coordinates, an x-coordinate and a y-coordinate. So this is called the y-intercept point. But the y value alone is simply called the y-intercept, right?
Right.
But together they call the y-intercept point. Okay, so if I select a point here, what's the x location of this point? The y location is 3, but what is the x location?
Give me a second. The y location is 3. The x location is 0.
All right, great. Location of this point here, right here.
Oh, that point. The x location of that point is 0.
Okay. For every point, let's call a point P. You have an x coordinate and a y coordinate. So the very first thing you're referring to is the x coordinate. So the very first thing is the x coordinate. So if I mention anything to the first one, it's called an x coordinate, right? So looking at this, what coordinate is this?
That is the x coordinate.
Thank you. Based on this is standard. And what's this? Which coordinate is this one?
Y coordinate.
Right. Y coordinate. Okay, good. So for the x axis, you move up and down to hit the x axis. Because you have to do that, because there's no other way of getting to the x axis. So you go straight up the shortest distance. What's the shortest distance to reach the x axis? If you go like this, it's going to take you longer. The shortest distance is to go straight up to the x axis. Another way of thinking about it. If you go this way and then turn up, right? It's not a short distance. The shortest distance. Shortest distance is simply walking straight up to the x-axis. So if you're right here, what's the shortest distance of reaching the x-axis?
Going downwards.
Straight down. Because you could go sideways, so downwards, but going straight down, correct?
Yeah.
So for this point, what is its x location? You go straight down on the x-axis. For this point down here, to locate its x coordinate, you go straight up to the x-axis. All right, so let's look at another one. Let's call this point A. What is its x location?
Its x location is 0.
Okay, how do we know that?
By going straight down the x-axis.
To going straight down?
Yes.
To finish it off?
Downwards.
To what? To where?
Towards the axis.
There is a x-axis and there is the y-axis.
The x-axis.
The x-axis. It's also going to be the center of the y-axis, yes, but we're just thinking, since it's the first one we're looking at, we're just thinking of the x-axis. We're thinking about the x-axis, regardless to where it is. So what is here, we go down to the x-axis. What is here, we go down to the x-axis the same. What is here, we go down to the x-axis the same. What is here, we go down to the x-axis.
The coordinates of the point is 0.
Okay, 0, fine.
And the other one is 2.
Okay, great. Okay, good. All right, so what are the coordinates?
The coordinates are 0 and -1.
Okay, what about this one?
Coordinates are 0 and -4.
Okay, what about this one?
Coordinates are 0 and 1.
Okay, good. What is common among all these points found on the y-axis? Look back at this standard, and you're seeing the first thing you're seeing is an x. I would call it the x coordinate, right? X coordinate. And this second one, we call it the y coordinate. So we have this as is a point that we have here. It has an x coordinate and has a y coordinate. So what I wanted to use the jargon, I use those words or terminology now. This for any point, we have an x coordinate and a y coordinate. So you have a pair of coordinates in x coordinate and y coordinate for any point. So these are points that you can clearly see that they are on which axis? The y axis. And what all of these have in common?
The x coordinates are all the same. I'm telling you that they're all zeros, they're all the same.
Right.
For the x coordinate.
Or you can say the x coordinate of each point is 0.
Okay.
Right. So since the x coordinate of each point is 0, then we can call the y-axis what? The what axis? The x equal 0 axis.
0 axis. Yeah.
Got it?
Yeah.
So another way we can say that is that the equation of the x-axis is y equals 0. The equation of the y-axis is x equals 0. And that's another thing we want to look into, equations of straight lines. So the x-axis is a straight line. Do you agree?
Yeah.
And its equation is y equals 0. So equation is equal sign between two terms or more terms, two or more terms. So an equation is basically we have an equal sign between two or more terms. Y is a term and 0 is a term. So it's the y equals 0. It's an equation. So the equation of this straight line, which is an axis, is y equals 0. The equation of this straight line, which is the y-axis, is x equals 0. And we can clearly see that each point on the y-axis, x is 0. All right, so what did you learn so far? What can you remember?
What I can remember is the points for each intercept has 2 coordinates.
Very good. Well done. What else? The only point that can have coordinates being equal to both zeros is the origin. The origin is located at 0, 0. Any point at the origin, if you have a point at the origin here, it has coordinates 0, 0. But there's no other point that has 0, 0 location. The only 0, 0 location is right at the center. But if you notice these, the coordinates are not equal to 0. Yes, one of the coordinates is equal to 0. In these cases, one of the coordinates is equal to 0. But you cannot say that the coordinates are equal to 0. What coordinate is equal to 0? So you need to specify which coordinate is equal to 0. And for the points on the x-axis and y-axis, it's not the same set of coordinates that are equal to 0. Look at the coordinates on the x-axis. Which coordinates are always 0?
y coordinate.
Look at the y-axis. The points on the y-axis. Which coordinates of the point are always 0? Which coordinate of the point?
The
Right,
x.
right. This line is called what? The x-axis. It's the line that's called the x-axis. Right? The dots on them are called what? This is called a what? A point. A
Points
point on the line. Or in this case, what kind of line? The x-axis.
for the y axis.
Okay, so you're talking about this vertical line here.
Yeah.
What about it?
The the x coordinate.
Of what? Now these are these things that are on
The
the x
the
on the
point.
y-axis. We call them what? Points, right?
Right.
So let me call. So let's want to help you with that. These are called points. Go ahead.
So the points on the y-axis,
Mm-hmm.
the x coordinates are equal to 0.
Right. Very good. And these are called the x coordinates. Good. And go ahead with the others now.
And for the x-axis,
Mm-hmm.
the points on the x-axis,
Right. Which are these things? So called the points. Yeah.
the y coordinates
Mhm.
are equal to 0.
Very good. I feel so proud of you.
I've learned that their center of um, the coordinate plane is called the center of the origin or the origin.
Not the center of the origin, just the origin. The
Okay,
center.
it's called the origin.
Okay, here's a better way to express that. Is there a better way you can express that in your own words, based on what you can see?
So point where the y and x axis meets is called the origin.
Very good. Well said. That's the most accurate way of expressing it. So where the x-axis, since you know the names, you're getting familiar with the names. So where the x-axis and the y-axis meet, you call it the what?
The origin.
The origin. Very good.
And I've learned that the four, okay, the plane
Right, the
as
coordinate.
divided into 4 quadrants.
Right, the coordinate plane is divided into 4 quadrants. Very good. 4 quadrants. For points
4
found
points
in
found
the
in the first quadrant.
mhm,
There
x
and
coordinate is positive and the y coordinate is
positive.
right. For points found in the second quadrant,
For points found in the second quadrant, the x coordinate is negative and the y coordinate is positive.
good. For
And
points found in the
for points found in the third quadrant,
mhm,
the the x coordinate the x coordinate is negative and the y coordinate is negative.
mhm,
And for points found in the fourth quadrant,
mhm.
the x coordinate is positive and the y coordinate is negative.
All right, so you understand that. So you also learn that when the straight line crosses the y-intercept, what we call that?
When the straight line crosses the
Y-axis.
y-axis,
Mhm.
it is called an intercept and
Intercept.
it's called intercept.
Yeah. Look at which intercept when it cross the y-axis.
And y-intercept.
When it cross the x-axis, we call it the what?
The Xintercept.
The Xintercept. Very good. What if you have a if how many intercept this graph has?
It has it has one.
One right here, right?
The Y, yeah,
What would you call that? The what?
the Y axis, the Yintercept.
For that particular graph, right?
Yeah,
And what its value is?
2.
2. What is the y-intercept point of this y-intercept point? The y-intercept point of this graph.
The Y-intercept point of that graph is
Think about it first.
it's 0
0, uh-huh.
and 2.
Right. I remember there's a relationship between what? The intercept point and the intercept. They're the same value, right? The y
Yeah,
coordinate of the y-intercept point, the y coordinate of the y-intercept point is called a y-intercept. Remember that? The y
sorry,
co the
the
y
Y,
coordinate of the y-intercept
uh-huh,
point is called the y-intercept.
okay,
Did you remember that?
yeah,
It's the y-intercept point, yes, with two coordinates. But the y value is
right.
simply called the y-intercept. In terms of the x-intercept, what are the how many places does it cut the x-axis?
2,
Right. So it has how many x-intercepts?
2.
Right. What are they? What's it?
It's 1,
One.
1 as the X-intercept, and the intercept point, it's 0 and 1.
Okay, before you do that, what's this is the x-intercept, right?
Yeah,
Is this x-intercept as well?
yeah.
What is the value there?
For the one over there,
Yeah, yeah.
that's that's 5.
Okay. And if you want to give me the point now, what is the point?
1 and 0.
Yes.
We're
Yeah.
doing the
What
X coordinate first.
what do you always write first?
X before the Y.
All the time, in every instant.
Right. So, for the one that we did at the top, X first, Y second. This one to the bottom that we're doing, if I'm doing X first, is not going to the left to
No,
the origin point
no,
to get the 0.
no. But you're not trying to get the zero now. You're trying to hit the x-axis. Aren't you already on the x-axis?
Yeah.
The reason to move towards the left or right is to go on the
Oh,
y-axis.
okay, okay. I get what you're saying because we are already on the x-axis.
Right. And you never
Okay.
you never move left or right to go on the x-axis. You only move up, you move up or down. Think about it. Remember we said if a point is somewhere out here, you don't go across the y-axis to get the x value. You simply go down to the x-axis. But this is already on the x-axis. So anyways, look
Right.
at this. If I put a straight line here, where does this straight line cut? Which axis does this straight line cut?
The x-axis.
The x-axis. What that means that any point found on the straight line, any point found on the straight line will have an x coordinate. Remember, it's points that make up a that create a straight line. A straight line is an infinite amount of points because I could just put points, points, points everywhere until they form a smooth line going all the way down. So a point is really made up of points, infinite amount of points going right down. And when it looks smooth, it looks like a straight line. But every straight line is really a combination of infinite amount of points. Never ending amount of points. So give it a smooth look. But all of these points, right, has a location as an x location of 1 because the straight line cuts through the x-axis at 1. So this point will be 0, sorry, not 0, but 1, 1, 2. This has 1. I'm saying one thing right in the next. Give me a second. So this will be 1, 2. This will be 1, 1. This will be 1, 0. Right? This will be 1, negative 1. This will be 1, negative 2. Realize the consistency. All these values are 1 because the straight line itself cuts the y-axis, the x-axis. Why did I put x-axis down here? It should be x-axis. Right? The straight line cuts the x-axis at what? In fact, the equation of this line here, just like the equation of the y-axis is x equals 0, the equation of this line here is x equal 1. Because every x value is equal to 1. For every point found on this line, the x values are equal to 1. So that means this equation of this line is x equal 1. Every point found on this line, the x coordinate is 0. So no matter where the point is found, you have to go down to the x-axis at 0. So every point found on this line, you see x is equal to 0. And the same if you put a line here, all of the x values will be equal to 3. Same if you put a line here, all the x values will be equal to negative 5. Got it?
Yeah.
Sure?
I think so.
All right. So the x coordinate of this point is what? 1. And all I see is this upright. Remember, no, remember. The y-axis is like this, a straight line like this, coming down here. You're seeing what? This is y-axis. You're seeing 3. You're seeing, so on the y-axis, this value is what? 3, right? Then 2, then 1, then what? What's this now? 3, 2, 1. What's the next one? 0.
0.
Then negative 1, right? So if a point is here, its y location is 3. If a point is here, its y location is 2. If a point is here, its y location is 1. If a point is here, its y location is what?
0.
0, right? And if I draw a line straight through this, you realize it cuts that straight through that point, which is, and this point is, and this is really called the x-axis. But you're not thinking about the x-axis. You're thinking about the point that's right here. Always on the x-axis, it still pass through. It still will have to hit the y-axis, this line, at 0. Just as this one hits it at 1, this one hits it at 2, this one hits it at 3. Then this point following the same pattern will hit the y-axis at 0 without thinking about the x-axis itself. So this point here will hit the x-axis at 0. This point here will hit the x-axis, not, oh my god, what am I saying? This point here will hit the y-axis at 0. This point here will hit the y-axis, this vertical axis, up and down axis, at 0. So while the x coordinate is 1, the y coordinate is 0. So you always start with x first. The point is actually on the x-axis, so you don't need to go anywhere to get the x value. The x location is 1. You don't need to go anywhere else to get the x coordinate because it's already on the x-axis. For this point, you have to move it downwards to hit the x-axis to find the x coordinate. So we say that the x coordinate is 4. 4, and the y value is 3 for this point. But this one is already on the x-axis, so its location is 1. 1 what? 1, 0. Understand?
Yeah. Yeah.
The 0, 1 that we have here is remember, this is this point, you know, remember I actually drew an arrow here, so don't get confused with this. This belongs to this over here. But this point has an x coordinate and y coordinate of 1, 0 respectively. This point here has a what? An x coordinate of what? What's the x coordinate of this point?
Which point?
This one.
5.
What's the y coordinate? Right. It's like when you have a graph when I have a graph touching the y-axis, the location is always 0, C. Meaning you always have a 0 for the x value, but the y value is C. Can be any number.
Okay.
In this case, C is actually 1. But 0 comes first, but C takes on any value. But the first value is always 0. Once it's the y-intercept, first value is always 0. Once the y-intercept. For the x-intercept, it's always A, 0. The first value can be any number, but the second one is always 0. So for example, what are the coordinates of this point here? What are the coordinates of this point? Second coordinate is always 0. The y-coordinate of any point on this line is always 0. What is the first coordinate though of this point right here? You can see it. What's the coordinate? What's the x-coordinate?
Sorry, internet. The x coordinate is -5.
Right. So that's why it's called A0. For the first one, it can be any value, but the second one's always 0. What about this one? This one is still the same thing since the x-intercept is going to give us A0 as well. So what's A and the next, what's A in this case?
A is -1.
And the y coordinate is what?
0.
Right. And by the way, we call this a solution too. We call this a solution. Call this a solution to both equations. Where both of them cross each other, we call it the solution to both graphs. So the solution is 0, 0, 1. 0 on the x-axis. If you just let this y-axis disappear, you realize you'll hit the x-axis at 0. You know to identify these points. But I find that you're struggling to identify points that are found on the axes themselves. With practice, you'll get it. Just remember, the coordinates of points on the x-axis, y is 0. The coordinates of points on the y-axis, x is 0.